Okay. In the last class we seen about my voice is audible. Give response. Hello. Hello. Okay. So in the last class
Yes,
we
sir,
see.
it is audible.
Yes. In the last class we seen about what we have seen in the last class. Anybody give response? In the last class what we have seen? Like gated latch, no? Gated SR latch and gated D latch. Okay. We have seen in the last class. Last class we have seen. Okay. Today we'll see the SR flip flops. Okay. One second. Flip flops. Okay. So. Okay. We'll see about flip flops. Okay. So if you know the operation of this gated D latch flip flops, so no need to say the operation. So in the flip flops, that means here in the place of enable pin, there is a there is a clock. Okay, in place of enable signal, there is a clock. Okay, so we'll see the flip flops. What are flip flops? Okay, so flip flops. Okay. Basically, first we'll see the SR flip flop. Okay, first we'll see the SR flip flop. What is this SR flip flop? So in SR flip flop, we'll see the characteristic table, truth table, excitation table, and also state diagram. Okay, so SR flip flop. SR flip flop. Okay, so if you see the SR flip flop, the diagram will be like the basic block diagram will be like this. So this is S and this is R, and there is a clock. This is S and this is R, and there is a positive S trigger clock, and output is Q and so Q bar. Okay, Q and Q bar. So this is the basic block diagram of SR flip flop. So if you see the logic diagram, so if you see the logic diagram, this will be like so one NAND gate, another NAND gate. So these two NAND gates you are giving S. You are giving S and R and common clock for two flip flops. Okay, common clock for two flip flops. Again, this is given to one second. I will take the PPT. Here it's not. One second. Restrict online. Okay. Okay. So I'll change the color. So the block, so SR flip flop. So we are discussing the SR flip flop. So SR flip flop block diagram already drawn, and the basic logic gate diagram if you see. One second. Basic diagram will be, this is NAND gate, and this is one more NAND gate. Okay, common clock for two NAND gates. This is S and this is R. Okay, and this is one more NAND gate, and this is one more NAND gate. Okay, so this will be feedback. And this is nothing but Q bar. Okay, so block diagram will be like this. This is S and this is R. Okay, and next here this is nothing but Q and Q bar. Okay, so if you see the characteristic table, one second. Characteristic table. So what are the inputs? S, R and Qn. Okay, so here present state is what? Present state is Qn bar. Present state is Qn bar. And the next state, what is the next state? Qn plus 1 and Qn plus 1 bar. Okay, that operation already we discussed in the latch, gated SR latch. Okay, so how many possible combinations? Total you have 8 possible combinations: 0 1 0, 0 1 1, and next 1 0 0. Okay, 1 0 0, 1 0 0. One second. Okay, so SR flip-flop, okay, so if you see that is the block diagram, and here S, R, Qn and Qn plus 1. Okay, so if you see, so how many possible combinations? 0 0 0, 0 0 1, and next 0 1 0, 0 1 1, and next 1 0 0, 1 0 1, and next 1 1 0, 1 1 1. Okay, so that means we already seen the truth table of a gated SR latch. So that means 0 0 when s equal to 0 r equal to 0, it will be in which state? Memory state. Okay, so this is nothing but state, memory state. Okay, and when s equal to 0 r equal to 1 means it will be in which state? Reset state, reset state. And when s equal to 1 r equal to 0, it will be set state. And this is don't care. Okay, this is don't care. Okay, so this is characteristic table. And how to draw the truth table? This is characteristic table. Okay, so how to draw the truth table? So truth table is so here clock is also there. Okay, here clock is also there. Okay, so when clock is 1, then it will be activated. Okay, so when clock is 1, so this will be activated. Okay, so when negative edge of trigger, negative edge trigger clock, it will be not activating. Okay, so that means you can write like clock yes or qn plus 1 state, qn plus 1 state. Okay, so if you see so whatever, suppose if it is clock is a negative edge trigger. Okay, so here this is negative edge trigger. So negative edge trigger means either whatever may be the s and r. Okay, so it will be in the previous state, so that we call as memory state. Okay, at negative edge trigger, so at positive edge trigger only the output will change. Okay, so here when positive edge trigger, so when it is positive edge trigger, so what happens? 4 possible combinations, 0 0 0 1, next 1 0 1 1. Okay, so tell me the case. You see the characteristic table and you need to draw the truth table. So that means this is what, this is a memory state only. The state is memory state. Okay, memory state. And this is nothing but reset state, and 1 means what? Set state, and here this is the invalid state. Okay, so this is the characteristic table and truth table. Excitation table. So how to draw the excitation table? Okay, so I'll draw the excitation table. So excitation table is nothing but what? By seeing the inputs. Okay, so excitation table. So if you see the excitation table, okay, excitation table. So S R, okay, not S and R. You need to see the present state and next state, and you need to find out the find out the inputs. Okay, that is nothing but excitation table. Okay, so 1 second. The excitation table. So if you see the excitation table, so if you see the excitation table, okay, so present state qn plus 1, the output sr, okay, so 0 0 0 1 1 0 and 1 1. Okay, 1 0 and 1 1. Okay, so you need to see the characteristic table and you need to get the excitation table. So see the characteristic table. That means when it is 0 0, so what is s and r? When it is 0 0, s and r are 0 0. Okay, so that means here I am writing qn and qn plus 1. Okay, qn plus 1, s and r. Okay, so when it is 0 0, what are qn is qn plus 1 is 0 0. What are s and r values? 0 0. Okay, and next case, when qn and qn plus 1, this is first case only. First case, when it is 0 0, s and r values are nothing but 1 0. Okay, so 1 0 means you can write this is as a what? The 0 don't care. Okay, so this is don't care 0. You can write as don't care 0. Why? Because two possible values are there, 0 0 and 1 0. So S and S is 0 1 means you can write as don't care, and R is anyway 0. Okay, that is a possibility. And second possibility I am taking when Q and Qn plus 1 is 0 1. Okay, so when it is 0 1, this only, no, so this is second one. Okay, so when it is 0 1, what are S and R values? When it is 0 1, S and R values are 1 0. Okay, S and R values are 1 0. Okay, 1 0 and 1 0 1 0. So third case, if you see, when it is 1 0 0 1. Okay, this is nothing but 0 1. Okay, and next when S and R values, so the Qn plus 1, S and R. Okay, S and R, when it is 1 1. Okay, what are S and R values? So let us take this is fourth one, and this is fourth one. Okay, so fourth case if you see 1 1, this is nothing but 0 0, and next case is 0 1. You can write this as what? 0 don't care. Okay, this is nothing but what? 0 don't care. Okay, so this is the excitation table. So how to remember means one method is directly we can remember like don't care 0 1 0 0 1 0 don't care, or like if you remember one thing like don't care 1 0 0, that will come in the reverse in the R, that is don't care 1 0 0. Okay, so this is the excitation table. Okay, this is the characters table, and this is the truth table, and this is the excitation table. Okay, from the excitation table you can draw the state diagram. Okay, so how to draw the state diagram? So here so let us take the, how many states are there? 2 states are there. Okay, so 2 states are there. So present state and next state. Okay, present state and next state, and what are this S and R values? Okay, S and R values. So how to draw the excitation table? So that means here 2 states are there. So this is the 0 state and this is 1 state. Okay, so if you see present state is 0, present state is 0, next state is what? Next state is same 0. What are the inputs? So it will be in the same state. What are the inputs? Don't care 0. Okay, and when present state is 0, next state is 1, it is going to the next state 1. Okay, next state 1, the inputs are 1 0. Okay, and at 1 I am saying, okay, at 1 present state is 1, next state is what? 0. What are the inputs? 0 1. Okay, and here present state is 1, the next state is same, okay, so what are the inputs? 0 don't care. Okay, so 0 don't care. So like this you need to draw the state diagram. Okay, state diagram. Is this characteristic table, truth table, excitation table, and state diagram are fine? Please give response. Tell me. Hello? Anyone? Yes? Okay. Shall you note down or shall I move forward? Shall you note down this? Your response.
Yes, sir.
Okay. You note down. Truth table also I can draw. So characteristic equation also I can draw. What is characteristic equation? That is Qn plus 1 equal to you need to get the characteristic equation. So that means Qn plus 1 equal to that is equal to what? Summation of m of what, wherever the ones are there, 1 next 1 4 5, and what are don't cares? Don't cares are 6 comma 7. Okay, don't cares are 6 comma 7. Draw the K map, and get the expression. Okay, draw the K map and get the expression. You will get the characteristic equation. Okay, characteristic equation. Okay, you understood how I am drawing the K map and all these things. Okay, if you draw the K map, you will get the characteristic equation. Okay, so I need to draw the K map. See, here I am drawing the K map. So here I am drawing the K map. So what are the inputs? Inputs are S, R, Qn. Okay, 0, 1. Okay, 0, 0, 0, 1, 1, 0, 1, 1. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Okay, so whatever the ones are there, you need to write 1, 4, 5, and what I don't care, 6 and 7. Okay, so depending on the possibility, I can consider don't care as 1. So this is one quad and this is one pair. Okay, so quad means you are getting what? So this is S. Okay, pair means here you are getting R bar Qn. Okay, so what is my Qn plus 1 characteristic equation? What is my Qn plus 1? S plus R bar Qn. S plus R bar Qn. Okay, so this is my characteristic equation. Is it fine? Characteristic table, truth table, excitation table, state diagram, and characteristic equation. Is these are fine?
Yes, sir.
Okay. No doubt. Please let me know after you are completing. I will move forward. Yeah. One second. Somebody is getting to join. Okay. Who is trying to join? Somebody is trying to join. One second. But where I can join means I'm not seeing. Okay, one second. Okay. Yeah, completed. Your response? Okay. Suppose if I want to draw for T flip flop, okay. So T flip flop excitation table, truth table, okay. Not T flip flop. From the SR flip flop, you will get which flip flop? D flip flop, no? Okay. So D flip flop you will get, okay. So D flip flop, you need to draw characteristic table, okay. Need to draw characteristic table. So you need to draw the characteristic table and truth table, excitation table, and state diagram, characteristic equation. Okay. So if you see the D flip flop, so delay flip flop or D flip flop, so this is used as a sequential buffer. So just clock is different as we discussed in the gated D latch. Okay. So this is D and this is Q, okay, and this is Q bar. So what is characteristic table? So here if you see D, next Qn plus 1, okay, Qn plus 1. So here if you see how many possible combination? 4 possible combination: 0 0 0 1 1 0 1 1. Okay, and so that means if it is 0 0, okay, if it is 0 0, what you will get? 0 0 means whatever the D input is there you are getting, okay. So that means here you are getting 0 0 only. If it is 1 1, whatever the D input is there you are getting with the same thing, okay. So this is characteristic table. And truth table, so truth table is nothing but D, next Qn plus 1, and next state, okay. So state, so here this is 0 means what? 0, okay. So this is nothing but reset state. 1 means 1, okay, this is set state, okay. This is truth table. And coming to the excitation table, so excitation table, from the characteristic table you will get the excitation table, okay. So present state and next state, present state and next state, you need to get the input, that is nothing but excitation table, okay. So these excitation tables you need to remember. Why? Because these excitation tables we are going to use in the flip flop conversions as well as in the counters. While you are designing a synchronous counter, you are using this excitation table, okay. You need to remember all these things, okay. How many possible combinations? 0 0 0 1 1 0 and 1 1, okay. 1 0 and 1 1. So you need to see the characteristic table and you need to get the excitation table. So if you see the characteristic table, so tell me, so that means 0 0. So 0 0 means what? This is first one. 0 0 means what? 0 only, okay. This is D, sorry, D, okay. So this is 0 and 0 1, okay. This case, second case, 0 1, this is 1 1 0. 1 0 means what? 1 0, present state and next state is 1 0, D input is 0, okay. 1 1, D input is 1, okay. So this is the excitation table, okay. So by seeing the excitation table you need to draw the state diagram, okay. So how many states are there? 2 states are there. So one is 0 state and next one is 1 state. Okay, so that means when the present state is 0, next state is same. So what is the D input? 0. By see this one, present state. So this is present state and this is nothing but next state, and these are nothing but inputs. Okay, these are nothing but inputs. And when present state is 0, next state, so it is going from 0 to 1, 0 to 1, and the input is 1. Input is 1. Okay, and you are at 1. Okay, you are at 1. Present state is 1. What is the next state? 0. Okay, so what is the input? 0. Okay, and see this one. So when present state is 1, next state is same state. What is the input? 1. So input is 1. Okay, so this is the state diagram. Okay, this is the state diagram. Okay, state diagram. And from characteristic table you will get the characteristic equation. Okay, so how to get the characteristic equation? You need to draw the K map. Okay, or directly you can write like here. Okay, I will draw the K map and I will show you how we are getting the characteristic table. So this is two variable K map. Okay, so two variable K map, and inputs are what? D and Qn, and 0 1 0 1. Okay, 0 1 2 3. Okay, and this is 1 1. 1 1 means this is one pair. Pair will emanate one variable. So if you write for this one, this is nothing but D. Okay, so you need to draw the K map for next state, Qn plus 1. Okay, so Qn plus 1 equal to what? D. Qn plus 1 equal to D. So this is the characteristic equation. Is it fine? Do you understood how I am drawing the characteristic table, truth table, excitation table, state diagram, characteristic equation for the D flip flop? This is clock. This is clock. Give response. You understood or not?
Yes, sir.
Yeah, note down. Shall I move forward? Shall I move forward? Give response. Okay. So next you need to draw the JK. Next is JK flip flop, no? So JK flip flop. So JK flip flop. So characteristic table, truth table, characteristic equation, excitation table, okay, and next state diagram. Okay, state diagram you need to draw for JK flip flop. Okay, so first I am drawing the characteristic table. So anyway, block diagram, you know, so that means 2 inputs are there. So this is the block diagram, J, K. So J, K, same as J gated J latch, gated JK latch we have seen, no? So this is a Q and this is Q bar. Okay, so inside that will be logic, same logic. In place of enable pin you have clock. Okay, that is the only difference. Okay, that operation also we seen. Okay, so here so J, K, next Qn. Okay, J, K, Qn, and next Qn plus 1. Okay, so 0 0 0 0 0 1, and next 0 1 0 0 1 0 0 1 1, and next 1 0 0 1 0 1 1 1 0 1 1 1. Okay, so that means here in SR flip flop there is an unused state. That unused state we are going to use in the JK flip flop. Okay, so that's why we are going with JK flip flop. So this is nothing but memory state, and this is nothing but reset state, and this is nothing but set state, and this is nothing but toggle state. Okay, so toggle state and truth table. So if you draw the truth table from the characteristic table, you will get the truth table. So J, K, and Qn plus 1. Okay, Qn plus 1 and state of the flip flop. Okay, so 0 0, what is the state? Memory state. 0 1 0, reset state. Okay, and 1 0 means 1, set state. Okay, and 1 1, this is nothing but Qn bar is nothing but toggle state. Okay, so you have the truth table. And how to draw the excitation table? From the characteristic table you will get the excitation table. Okay, so I am drawing the excitation table. 1 second, the color. Okay, so you see so excitation table Qn plus 1, and J and K. Okay, J and K. So see here, first step. So that means when Qn, so possibility is 0 0 0 1 1 0 1 1. Okay, so when Qn plus 1 are 0 0, so what are J and K values? Okay, so this is the 0 0, this is first case. When it is 0 0, J and K values are 0 0, and Qn plus 1 are 0 0, this is first case. 0 1. Okay, 0 1. So this you can write as what? 0 don't care. Okay, this is nothing but 0 don't care. Okay, and next 0 1 you see. So this is second case, 0 1. So 0 1 means not this one, sorry, not this one. 1 second. Not this one. Which one? 0 1. So 0 1 is, this is second case. 0 1 and this is 0 1. Okay, so 0 1 means what you are getting? 1 0 and 1 1 you are getting. Okay, 1 0 1 1 means what? You can write 1 don't care. Okay, so 1 don't care you are getting. Okay, and next Qn qn plus 1 j k. Okay, next state is 1 0. Okay, if it is 1 0, so if it is 1 0, this is third case. 1 0, third case. Okay, if you see the third case, 0 1 0 1 and 1 1. So if you combine, what you are getting? Don't care 1. This is nothing but don't care 1. Okay, and next 1 1 you see. So this is fourth case. This is fourth case. Okay, so if you see this one, this is nothing but 0 0 and 0 0 and 1 0. Okay, this is nothing but don't care 0. Okay, this is nothing but don't care 0. Don't care 0. Okay, so for the excitation table for JK flip flop is 0 don't care, 1 don't care 1, don't care 0. Or you can remember like this: 0 1 don't care, or 0 1 don't care. Okay, like this also you can remember. So from the excitation table you will get the state diagram, no? So if you want to draw the state diagram, so first state is 0 and second state is what? 1. Okay, so when it is present state is 0, next state is same 0. What are the inputs? Inputs are 0 don't care, 0 don't care. Okay, 0 don't care. When present state is 0, it is going from next state 0 to 1. What are the inputs? 1 don't care. Okay, and at 1, at present state is 1, next state is 0, next state is 0, and what are the inputs? Don't care 1. Okay, when present state is 1, the next state is same, next state is same. What are the inputs? Don't care 0. Okay, so this is the state diagram. Okay, how we will get the characteristic equation? From the characteristic table we will get the characteristic equation. Okay, so that means you can write qn plus 1 equal to what? Summation of m of, tell me the min terms, 1 next 4 6 and 7. Okay, so these are the min terms. Based on the min terms you need to draw the k map. Okay, so this is j and this is k qn. 0 1 0 0 0 1 1 0 1 1. Okay, 0 1 2 3 4 5 6 7. Okay, so I am drawing the I'm entering the min terms: 1 4 6 6 7. Okay, one second. J plus A into Q dash. Okay, 1 4 second 1 4. Sorry, this is 5, no? Sorry, this is 5, not 6. 1 4 5 7. Okay, so this is 1. Okay, this is 6 is not there, I think. 1 1 4 5 6. Okay, 7 is not there. 1 4 5 6. Okay, 7 is not there. Okay, so that means this is one pair. Corner grouping is allowed. This is one pair. Okay, so pair will emanate one variable. So here if you see, this is nothing but what? This is nothing but k bar qn. Okay, this is nothing but what? j qn bar. Okay, so now what is my qn plus 1? Qn plus 1 equal to qn plus 1 equal to j qn bar plus k bar qn. Okay, this is the characteristic equation. Is it fine? Do you understood how I am doing? How the things are happening? Please give response. Yeah? Do you understood?
Yes, sir.
Yeah, note down. After noting down, please let me know. I will move forward.
completed, sir.
Yeah. Okay. One second. Okay. Next, you need to draw the T flip-flop, no? So from the JK flip-flop, how will you get the T flip-flop? When both are connected together, so from SR flip-flop you will get the D flip-flop. When S and R are connected with an inverter, okay? That we already seen in the gated latches. Same like that you have in flip-flops. So you have JK flip-flop. So when JK flip-flops, when inputs are tied together, okay, you will get a T flip-flop. Okay, so that means if you see the T flip-flop, so how we can draw the T flip-flop? So that means this is one JK flip-flop. This is one JK flip-flop. So J and K are inputs, and this is passage of clock, and inputs are tied together. Okay, so inputs are tied together. This is you are giving as input T. Okay, and this is nothing but Q, and this is nothing but Q bar. Okay, this is nothing but T flip-flop. Okay, so you need to draw the characteristic table, truth table, excitation table. Okay, and next characteristic equation, and also state diagram. Okay, these we need to draw for T flip-flop. Okay, so first we'll see the characteristic table. Okay, so characteristic table, so that means T, next Qn and Qn plus 1. Okay, T, Qn and Qn plus 1. So two inputs are there. How many possible combinations? 4 possible combinations: 0 0 0 1 1 0 1 1. Okay, so that means when T equal to 0 it will be in the same state, and when T equal to 1 it will toggle. Okay, so when Qn is 0 1, same state, that is memory state 0 1, and it is 0 0 when T equal to 1 it will toggle. That means present state is 0 1, the next state will be 1 0. Okay, this is characteristic table. And next coming to the truth table, so T, next Qn and state. Okay, state. So when T equal to when T equal to 0, okay, so memory state, no, memory state. When T equal to 1, that is Qn bar. Qn bar is nothing but which state? Toggle state. Okay, toggle state. And next I want to draw the excitation table. So how to draw the excitation table? So if you see, I want to draw the excitation table. So I want to draw the excitation table. So excitation table. So present state, next state, you need to get the inputs. With the present state and next state, you need to get the inputs. Okay, how many possible combinations? 4 possible combinations: 0 0 0 1 1 0 and 1 1. Okay, so you need to see when it is 0 0. Okay, this is the first case. With 0 0, what is T? 0. Okay, and when it is 0 1, this is second case. 0 1, present state is 0 and next state is 1, and this is T input is 1. Okay, 1 0, this is third state. 1 0, the T input is 1. Okay, 1 1, T input is what? 0. Okay, so if you see this one, it is looking like XOR gate, no? See here, for odd number of ones you are getting the output as 1, for same number of inputs you are getting the output as 0. So directly I can draw the characteristic equation. I can write the characteristic equation without drawing the K-map. So by observing this, I can say that T equal to what? Qn XOR of Qn plus 1. Qn XOR of Qn plus 1. Okay, so this is the T input. And next is state diagram, no? So next, how to draw the state diagram? By seeing the excitation table, you need to draw the state diagram. Okay, so two states are there. So this is 0 state, and this is nothing but 1 state. Okay, so present state is 0. So we are seeing this one. Present state is 0. What is the next state? It will be in the same state. Okay, it will be in the same state. What is the input? 0. Okay, next one, if you see, present state is 0, it is growing from 0 to 1. Okay, so what is the input? Input is 1. Okay, and at 1 you see present state is 1, it is coming to the next state 0, 0. What is the input? 1. Okay, if you see this one, present state is 1, present state is 1, it will be in the same state. What is the input? Input is 0. Okay, so this is the state diagram. Do you understood how I am drawing the state diagram? Give response. Anyone? One second.